Today's topic is transformations by replacing f of x. We're going to recognize vertical and horizontal transformations on parabolas today. Vocabulary: translation. It's a transformation that does not change shape or size of a function. We're going to be moving in either a vertical or horizontal direction. The first type of transformation is vertical, and it's the f of x plus k. If k is greater than 0, so if it's a positive number, you're going to move up. If k is less than 0, or a negative number, you're going to move down. But the parabola itself is going to stay the same size and shape, just move up or down vertically. The horizontal transformation, it's f of x plus k. You can see the difference that here k is added after the function, while here k is added within the function in a parenthesis. So with the parenthesis, it's a little opposite of what you would think. If k is greater than 0 or positive, you're going to move to the left. And if k is negative or less than 0, you're going to move to the right. Now, we've been saying that things inside the parentheses are opposite. So that's kind of a good idea for us to remember. One more vocab word is the parent function. Parent function is like the base function before any types of transformations happen. The parent function for quadratics is y equals x squared. You can see it starts at 0, 0 and has just a regular shape of a parabola. We're going to be referring to the parent function, and when we refer to it, we are referring to y equals x squared. Example 1, let's do some vertical shifts. So if f of x is x squared, or the parent function, we're going to describe vertical shifts, so we're going to use the f of x plus k if k is 2 and k is negative 3. If you're going to write down the new equation for this first one, it would be f of x equals x squared. Then we're going to add k after, so we're just going to add 2 after. This plus 2 tells us that we're going to move our function up 2. If you graph both the parent function and this function, you're going to get a shape like this. We can see the parent function here, the solid line, and we can see the transformation function right here, and we can see all that's happened is it's moved up 2 points. Every single point on the graph has just moved up 2 points. Let's see what happens if k is a negative. It would then give us f of x equals x squared minus 3. So instead of moving up, you're going to move down 3. If you look at the graphs, parent function's the solid one, and the new function is the dotted line. You can see every point has just moved down exactly 3 points. Same size, same shape, just shifted down. Horizontal shifts. So the difference now is the plus k is going to be within the function in the parentheses. So let's see what it looks like when you write it. So we're going to see for where k is 4 and where k is a negative 1. For k being 4, what's going to happen is the 4 is going to go with the x now in the parentheses. So we're going to have x plus 4 squared. Now, we've seen that things in the parentheses are opposite of what we thought. This is looking like vertex form if the k was 0. And the vertex would then be negative 4, 0. If you look at the new graph right here, you can see that the vertex has shifted over to negative 4, 0. So the shift is to the left 4, even though it says a plus 4. Now if k was a negative 1, we could write this as x minus 1 squared. And again, it's opposite of what you'd think. So the minus 1 really means we're going to shift to the right one. And we can see the shift move to the right one. Example 3, we're going to describe shifts by graphs. So we're going to graph the parent function. As a reminder, the parent function is y equals x squared. And then the new given function right here. And we're going to describe the shifts in words. Let's start by graphing the parent function first. I'm going to be doing two graphs on this, so I'm going to use two different colors. I recommend that. The parent function, you can use your graphing calculator to do this. If you graph it, it's going to have its vertex at 0, 0. And then to plot some more points, you have 1, 1. Its symmetrical point, negative 1, 1. 2, 4. And its symmetrical point, negative 2, 4. So there's our 5 points. Try to draw it with a smooth line. Alright, so there's our parent function. We're now going to graph this function, which is in vertex form, and see if the shifts occurred. Now, since it's in vertex form, I can identify the vertex by using h, which is going to be 3, not negative 3, and 4. This also helps me describe the different shifts. If you note the one inside the parentheses, right here, that's our horizontal shift. The one outside of the parentheses, that's our vertical shift. So let's start by graphing it. You can use your graphing calculator. So the vertex is at 3, 4, right here. And I need to plot a few more points. I can graph the next point 4 or 5, 2, 5. And let's do one more point, 1, 8, and 5, 8. There's our new parabola. Now these two parabolas are the exact same size and shape. This one's just been moved. We're going to describe how it's been moved both in the vertical and horizontal way. Now the one inside the parentheses is our horizontal shift. It said x minus 3, but remember that it's opposite of what you think, so instead of going to the left, the minus 3 really means you're shifting to the right. So we can say shift right 3, and then the vertical shift comes after the parentheses, that's the plus 4, and that went up, so shift up 4. That's what we're going to be doing, is describing these shifts in words and from a graph. Last example, we're going to describe the shifts from an equation. So this time we're not going to graph it at all, however you can always graph them to see a visual. We're going to describe the shift from the parent function, so again we're starting at y equals x squared. And we want to see if we can describe the shifts that occurred by just looking at the equation. Now again we have two different shifts. We have one inside the parenthesis and one outside the parenthesis. The one inside the parenthesis, that's our horizontal shift. And it says x plus 3, so think opposite. That really means it shifts to the left 3. And the plus 2 is our vertical shift. Oops, forgot to write this is our horizontal. And the vertical shift, since it says plus 2, that means we shifted up 2. So we can do it by either graphing both functions and looking, or just look at the equation. Lesson wrap up. If you still need help, rewatch this video, especially examples 3 and 4, or you can watch the additional resource videos or come in for help.